I think so. Okay, so here's your homework for assignment number 30. Hopefully you all got it stamped. So you only had 5 questions to answer, so that wasn't too bad. Question number 1 dealt with what are the assumptions of kinetic molecular theory. These are the assumptions that we gave in class. I changed number 1. In class, we actually said that the gases are really far apart. That means effectively gases have no volume, or at least the atom has no volume. So these are the assumptions that we turn out to make. Question 2 asks you what is an ideal gas, and it's anything that follows the 5 assumptions of kinetic molecular theory. So that's why it's called ideal, because it's following what we assume to be true. What we assume to be true is not true, so most gases are actually not ideal. Question number 3, you're being asked about pressure. So is there pressure inside, or why is there pressure inside of a closed container? And it has to do with the fact that gases are running into the container. When they run and they hit into something, that's a force per a section, and we call that pressure. 3b, you're asked to relate force per area with pressure, and pressure is just force per area, so it's a push or a collision over a certain amount of space. So the higher the push, the higher the force, the higher the pressure. Easy enough. Question 5, you're asked dealing with units. So for units of pressure, I just listed a whole bunch: kilopascals, bar, torr, millimeters of mercury, atmospheres, psi. You could use inches of mercury if you felt like it. There's all sorts of units that exist. I did have bar up there, so there's lots of units. Oh, atmospheres, ATM. 5b, you're asked how many millimeters of mercury is an atmosphere. It's 760. If you didn't know that, you could have just looked up in the book, because there's a table that tells you that. 5c, what's a Pascal? It's a Newton per square meter, which is the definition or the metric, or not the metric, but it's the SI, the System International version of a pressure unit. So when you take physics and you do all the math gives you answers in pascals, and anything else you have to do some conversions. For 5D, the SI unit is the Pascal, and an atmosphere is 101 kilopascals, which is 101,000 pascals. Question 6, the last one, you're asked about something called partial pressures, and basically partial pressures are each piece of gas. So if you have a mixture of gases, you have 3 gases, each of those gases are going to give a certain amount of pressure. And if I add up all 3 parts of, or all 3 pressures, so gas A's pressure, gas B's pressure, gas C's pressure, if I add them all up, I'm going to get a total pressure. And that's all we mean by partial pressure. It's a part of the total. 6b, you're asked, how does it influence the others? And the answer is, it doesn't matter, meaning gas A does nothing to gas B or to gas C, because it doesn't really turn out to matter. Gas A is gas A, and it doesn't care about any of the other gases, as long as they're not reacting. So hopefully you got this fixed. I'll post this online too. If you didn't get your homework stamped, hopefully you copied something down so you got something out of it, or you're going to finish up the homework. For your analysis questions, you had this to deal with. So if you need to pause this so you can quickly finish up your homework, feel free to, although you should have finished this. As a hint, 2, 3, and 4, they were all qualitative in nature. You never did any quantitative measuring. You dealt with no math. Question 1 we did yesterday, so hopefully you did that. Question 5, hopefully you finished your conclusion. So again, what am I looking for? I want to know what the lab was called. What were you attempting to do? What did you do? Give me some of your data. So you're going to give me some descriptions of what you observed. What did you analyze? Meaning, did you actually see the pressure-volume relationship? Did you see a pressure-temperature relationship? Did you see a volume-temperature relationship? Based upon that, did you actually answer what the problem was? Did you achieve that goal? And then, did you actually back it up? Meaning, oh, I said I did the problem of the lab, and here's how you know that I did it. It has nothing to do with, oh, I did the lab, and I filled out the data table, and I answered questions. That doesn't tell me anything outside of you've been trained to do that. The justification is, how do you know that you did what the lab told you to do? Meaning, how do you know that you did the problem? Hopefully you did all that. You could turn it in, you'll get credit, we'll smile, and move on with life.